we're looking at revision exercises on the chapters that has to do with calculation so far. And that will be on atoms, moles, formulae, and chemical equations. So this class is all about answering questions. And the first question here says the atomicity of ozone is A1, B2, C3, D4. Now, when we cover this aspect, we're told that atomicity is the number of atoms in one molecule of an element. Now, there are some elements that do not exist as a single atom. In other words, they have to combine either 2 or 3 atoms or more before they can exist as element. So such element, some of them may be diatomic, that is having 2 atoms. Others are triatomic, that is 3 atoms. Then anything more than 3, we can call polyatomic. For example, elements like hydrogen, oxygen, nitrogen, chlorine, all of that, whenever we write their symbol, we normally attach a 2 to it. Why can't we write O as in symbol for oxygen? But there is usually an O2. What is a 2 doing there? Because oxygen does not exist as a single atom. It must combine with another atom to form a molecule of oxygen. And so because in a molecule of oxygen, there are 2 atoms of oxygen, and we say that oxygen is diatomic. So this number of atoms in one molecule of an element is known as the atomicity of the element. For that of ozone is O3. O3, the 3 that signifies that there are 3 atoms of oxygen. There's 3 atoms of oxygen must combine before the element ozone can exist. And therefore, the question says atomicity of ozone is, the correct answer is C, 3. Then question 2 say 3NH3 is dash. A, 3 moles of ammonium? No. B, 3 moles of ammonia? No. Yes. C, 6 moles of ammonia? No. Then D, 6 moles of ammonium. So the right answer there is 3 moles. 3 moles. 3 moles of ammonia. 3 moles of ammonia. And question 3 said the relative molecular mass of lead 2 triazonitrate 5 is A 170, B 222, C 232, then D 132. Lead triazonitrate 5, the formula is PbNO3NO32. And they have given us the relative atomic masses of the respective element. Lead is 108, nitrogen is 14, oxygen is 16. So that will be 108 plus these 2 here affect both nitrogen and oxygen. So I'm going to place it in front to multiply all the relative atomic masses of this element here. So 14 for nitrogen, then oxygen is 16, but there are 3 atoms of oxygen there. So this will be 108 plus 2 times 16 times 3 is 48, then 48 plus 14, use a calculator there, 62. Then 62 multiplied by these 2 outside, 124. So this will be 108 plus 124, 332. What am I saying? 232 rather. Is the relative molecular mass of lead 2 triazonitrate 5. So for a question like this, that the formula of the compound is not given, we learn how to write formula of compound in one of our classes using the valency of the component, element, and radical. So in lead 2 triazonitrate 5, the component, element, and radical there are lead, and they have stated clearly that it is lead 2 to show that the oxidation number of lead in that compound is 2. That is 2. Then triazonitrate 5 is a radical, and the charge is 1 minus 1. And whenever groups, that is radical and element like this, whenever they combine, they exchange their combining power, that is their valency. So nitrate, we pick the 2 from lead, while lead, we pick the 1 from nitrate, so that the formula becomes Pb. Then because this 2 is going to nitrate, we have to enclose nitrate in a parenthesis, because that will affect the whole of the radical. That is how the formula is arrived at, lead 2 triazonitrate 5. Although most questions like this, but they don't, and you should be able to write it by yourself. Then question 4. Question 4 says, how many atoms are there in 1 mole of hydrogen molecule? 1 mole of hydrogen molecule. We learned that 1 mole of any substance usually contains 6.02 times 10 to the power 23 elementary entities. In this case, the question says how many atoms are there in 1 mole of hydrogen molecule? So the elementary entities of hydrogen molecule, hydrogen is of course an element. The elementary entities of an element are the atoms. So the question says how many atoms are in 1 mole of hydrogen molecule? So in 1 mole of hydrogen molecule, you have 6.02 times 10 to the power 23 atoms, the Avogadro's constant. So the right answer there is D. Oh, no, 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 no. D is molecule, so that is not the answer. Elementary entities of molecule of hydrogen is atom. So the correct answer is C. 6.02 times 10 to the power 23 atoms. Then question 5, we said the percentage of oxygen in sulfur 4 oxide is dash. Given that sulfur is 32, oxygen is 16. Sulfur 4 oxide, that is SO2. Now, we first of all need to get the molecular mass of this. Sulfur is 32, and plus oxygen is 16, but there are two atoms there, so 16 times 2. That will be 32 plus 32, which is 64. And then in this 64, how many, what did they ask us to? The percentage of oxygen, okay? Out of this 64, 32 is for oxygen. Therefore, percentage by mass of oxygen is equal to 32 over 64 times 100 over 1. At 32 divided 64, that is 0.5. Then multiplied by 100 is 50. So 50%. That will be B, option B. Then question 6 is from XNH3 gas, YO2 gas, given NO gas plus QH2O gas, the value of Z is, as we are to balance this equation, all these letters in front, X, Y, Z, and Q represent numerical coefficients of those substance or those compound. So how do we know those numerical coefficients? So let me rewrite it so we can balance it. We have NH3, that is ammonia, but we don't know the number of moles of ammonia there. It is represented by X there, plus oxygen, we don't know the number of moles, represented by Y. Gas, both of them are gas. Then giving us, where is it? Okay, oxide of nitrogen, gas. Also, we don't know the number of moles, so represent by letter Z, and plus water. Also, gas. Don't know the number of moles, so represented with Q. Now, to balance the equation, we do atom count on both sides, on the reactant and the product side. So, hydrogen on the reactant side is 3, but on the product side is 2. Hydrogen is not balanced. Nitrogen 1, nitrogen 1, nitrogen is balanced. Oxygen 2, oxygen 2, okay. So let's start by balancing this hydrogen. I'm going to convert this odd number of hydrogen, which is 3, to even number by placing a 2 in front of ammonia. If I place a 2 in front of ammonia, then that will give me, if I place a 2 also here to balance nitrogen, because these 2 here affect the nitrogen. So I also place a 2 here to balance the nitrogen on the product side, but that automatically change oxygen. So all in all, how many hydrogen do I have now on the reactant side? That is 2 times 6, which is 2 times 3, which is 6. So if I place a 3 here also to balance the hydrogen, that will give me oxygen, 3 oxygen here plus this, that is 5. That still does not balance the equation, so that will not work. Let's change this 2 here. Let's change it to 4 and see. If I change it to 4, that makes hydrogen to be 12. So to balance hydrogen on the product side, I'll have to put 6 here. So 6 times 2 is 12. And then that makes oxygen to be, this is affect oxygen too. So 6, let me first of all remove this 2 here. This 2 is coming from the previous attempt. So now placing a 4 here makes nitrogen to be 4 and hydrogen to be 12. So place a 6 here to balance the hydrogen. 6 times 2, 12. And this 6 affect this oxygen here, making the oxygen to be 6 plus 1 here. First of all, let's balance the nitrogen. No, you have nitrogen 4 here. So if we place a 4 here to balance the nitrogen, then that make 4 oxygen plus 6 oxygen here, that is 10. To balance it on the reactant side, we put a 5 here, so that the equation is now balanced. So 5 oxygen on the reactant side, 5 times 2 is 10. That is 10 oxygen on the reactant side. Then this 4 here affect the oxygen also. So 4 oxygen here plus this 6 here affect the oxygen here too, plus 6 oxygen. 4 plus 6 is 10. Then nitrogen is also balanced nitrogen. 12 hydrogen, that is 4 times 3, 6 times. That's to find the value of, what is the question again? You say from this equation here, the value of Z is dash. Look at where Z is. Z is the coefficient of NO. So the coefficient of NO in our balance equation here is 4. So the correct answer is A, option A. The relative molecular mass of CHO2, this two is supposed to be in subscript form. I forgot to do that. It's 60. Calculate the empirical formula. Suppose we calculate the molecular formula, not empirical formula. This is the empirical formula already. There's a mistake here. Calculate the molecular formula. Okay, now molecular formula, empirical formula multiplied by a multiple of n is equal to the relative molecular mass. That is, now expressing each of these in terms of their relative atomic mass, carbon is 12, hydrogen 1, oxygen is 16. So 12 plus 2, hydrogen is 1, but there are 2 atoms there, plus 16 times this n equal to 60. 12 plus 2 is 14. 14 plus 16 is 30. So 30 n equal to 60. N equal to 60 over 30, which is 2. Therefore, the molecular formula, let's see, let's start here. Molecular formula is equal to CH2O. Instead of n, now we are going to replace it with the value of n, which is 2. And then these two multiply all the atoms in the bracket, so that when we open up the bracket, we have C2H4O2. And this you can write according to the structural formula of the compound in question, CH3COOH, which is ethanoic acid. The 2 oxygen, then 4 hydrogen, you have 3 here plus 1, 4. Then carbon, 2, you have 1 here, you have 1 here. So this as formula is based on the structural formula of the compound, this compound, the condensed form of the structural formula. Then question 8, they calculate the relative molecular mass of the following slaked lime. Slaked lime is C8, has calcium hydroxide, and calcium is not given, but we know it. Calcium is 40 plus oxygen is 16, but these two here affect oxygen and hydrogen. It's a group here, this is a group. So the 2 outside the parentheses affect everything inside the parentheses. So let me place the 2 in front. Then oxygen is 16 plus hydrogen 1. This will be 40 plus 16 plus 1 is 17. Then 17 times 2, 34. 40 plus 34 by 74. So the relative molecular mass of slaked lime is 74. Relative does not have a unit. Anything relative does not have a unit. That's why we're not putting a unit. So question I, this is I. The next one is II. II says sodium triisonitrate 5, NaNO3. Sodium is 23, nitrogen is 14 times the 3 atoms. That will be 23 plus 14 plus 48. 23 plus 14, then plus 48. That is 85. So the relative molecular mass of sodium triisonitrate 5 is 85. Then the last one, hydrated copper 2 tetrazosulfate 6. That is Cu, question 3, Cu, SO4, then 5H2O. Okay? Copper is, what is the relative atomic mass of copper? Copper is 64, and 63.5, which is approximately 64. So 64 plus sulfur is 32. Then oxygen 16 times the 4 atoms there, then plus this 5 here, dehydrated salt, the molecule there, the 5 here affects all the atoms in front of it, that's hydrogen and oxygen. So I'm going to put it and use it to multiply the relative atomic mass of hydrogen and oxygen. Hydrogen is 1, but there are 2 atoms there. So 1 times 2 is 2, plus oxygen is 16. And this will be 64 plus 32 plus 16 times 4. That is 64. That's 64 plus 2 plus 16 is 18. 18 times 5, 90. So adding all of this together, 64 plus 32 plus 64 again, and plus 90, 250. So the relative molecular mass of copper 2 tetrasulfate 6 pentahydrate is 250, and mass of each of the following component elements in the respective compounds. The first one is sulfur in tetrasulfate 6 acid. Tetrasulfate 6 acid, that's H2SO4. First of all, get the relative molecular mass. Hydrogen is 1, 10 times 2 atoms, that is 2, plus oxygen, plus sulfur 32, and plus oxygen 16 times 4 atoms, which is 2 plus 32 plus 64. That will be 98. And now we have to calculate the percentage by mass of sulfur in this H2SO4. So what is the mass of sulfur in H2SO4? The mass is this 32 here. The percentage by mass of sulfur is equal to 32 over the relative molecular mass of the compound, which is 98, 10 times 100 over 1. 32 divided by 98, 0.3265 multiplied by 100, that is 32.65. That is the percentage by mass of sulfur in H2SO4. That is question A. Now question B says percentage by mass of phosphorus in tetraoxophosphate 6, tetraoxophosphate 5, which is H3PO4. Relative atomic mass of hydrogen is 1 times the 3 atoms there. That of phosphorus is 31. The percentage 31, 16 times the 4 atoms, then plus 31 plus 16 times 4, 64. 3 plus 31, that is 34. Then 34 plus 64, 98. A percentage by mass of phosphorus will be, in this 98, what is the mass of phosphorus in there? 31. Because you have only one atom of phosphorus. So 31 divided by 98 times 100 over 1. 31 by 98 is 0.3163, then multiply by 100, that is 31.63. 31.63%. Then question C, percentage by mass of oxygen in calcium triisonitrate 5. Let's make some room. Calcium triisonitrate 5, CaNO3, 2. Calcium is 40, plus these two affect both nitrogen and oxygen, so let's place it in front. 2 times nitrogen is 14, oxygen 16 times 3, 3 atom. That would be 40 plus 2 times 14 plus 48. 16 times 3 is 48. Now 14 plus 48, that is 62. And 62 multiplied by 2 there. 2 times 62 is 124. So this is 44, which is 164. 164. And we have to calculate percentage by mass of oxygen in it. Now in this 164, what is the mass of oxygen in there? Look at the position of oxygen. Oxygen here is 48. That's 16 times 3 because there are 3 atoms of oxygen. And then these two affect oxygen. So that would be these two multiplied by 48. So mass of oxygen then, mass of oxygen is 2 times 48, which is 96. So mass of oxygen in calcium triisonitrate 5 is 96. This is relative mass. So there's no unit. It's 96. Therefore, percentage by mass of oxygen is equal to 96 divided by the relative molecular mass, which is 164, and multiplied by 100. 96 divided by 164 and multiplied by 100 is 58.54. 58.54%. Then question 10 is to find the empirical formula of the following compounds from their percentage compositions. And let's get some room on this board. Okay, the question says find the empirical formula of the following compounds from their percentage composition by mass. The first one, we have nitrogen. The percentage composition by mass is 26.17. Then we have hydrogen. The percentage by mass is 7.48. Then we have chlorine. The percentage by mass is 66.35. Now, to find the empirical formula, remember that empirical formula is the simplest formula of a compound. It tells us the mole ratio in which the elements are combined. So we need to calculate the mole ratio of each of these component elements. And mole ratio is the reacting mass divided by relative atomic mass, or the percentage composition by mass divided by the relative atomic mass. So in this case, we have percentage composition by mass. So we are going to divide this percentage composition by mass of each of these component elements. That of nitrogen is 14, hydrogen is 1, chlorine is 35.5. Now 26.17 divided by 14, that is 1.8693. 1.8693. Then 7.48 divided by 1 still remain as 7.48. Then 66.35 divided by 35.5, 1.8690. Okay, now to get the mole ratio in which these component elements are combined, we need to divide each of these values by the smallest number. So comparing the three of them, which one is the smallest? The smallest is this last number here. So we divide through by this last number. That is divided by, we also divide this by that, 8690. Divide this by that also, 8690. Now 1 point, this should be 1. Let's see. 1.8693 divided by 1.8690 is 1 approximately. Then this is 1. Then 7.48 divided by 1.8690 is 4. And this one is 1. Therefore, the empirical formula is NH4Cl, which is ammonium chloride. Remember that some compound, their empirical formula and their molecular formula are the same. This is ammonium chloride. Then question B, we have calcium. Calcium, the percentage by mass is 71.43. Then oxygen, the percentage by mass is 28.57. To find the mole ratio, we divide each of these by their relative atomic mass. So the relative atomic mass of calcium is 40, that of oxygen is 16. 71.43 divided by 40 is 1.78575. Then 28.57 divided by 16, 1.7856, 1.7856 approximately. Now divide through by the smallest one. The numbers are almost the same, but this one is bigger. We got 7857. This one is 7856. So this is the smallest one. 1.78563. Only not the answer should be 1 there. 1.78575 divided by 1.78563. 1 approximately. 1. Therefore, the empirical formula of this is CaO, which is calcium oxide. In question C, silver percentage by mass is, what is it? 63.53. Then you have nitrogen, percentage by mass is 8.23. And then oxygen, percentage by mass is, what is this thing blocking me? Percentage by mass of oxygen is 28.24. Calculating the mole ratio of each of these component elements, we divide by their respective relative atomic mass. The relative atomic mass of silver is 108. 108. Nitrogen is 14. Oxygen is 16. So 63.53 divided by 108, 0.5882, and 8.23 divided by 14.5879, and 28.24 divided by 16, 1.765. We divide through by the smallest number. So let's compare the three of them and identify the smallest one. This is 5882, 588, but this one is 587, which means this is the smallest one. We divide by 5879, 879. So divide this by 0.5879. Now 0.5882 divided by 0.5879 is 1 approximately. We have 0.3 GNO3, which is 5. Component element sodium, percentage by mass is 32.40. And you have oxygen, percentage by mass is 45.07. And then sulfur, percentage by mass is 22.53. Dividing each of these by their relative atomic mass, that of sodium is 23, Oxygen is 16, sulfur is 32. To get the mole ratio, you have to divide each percentage composition by mass by the relative atomic mass of the element in question. And so 32 divided by 32.40 divided by 23 is 1.4087. And then 45.07 divided by 16, 2.8169. 22.53 divided by 32.7041. To get the ratio in which these elements combine in this compound, we have to identify the smallest number here and use it to divide through. So the smallest number is 0. Divide it here also. 1.4087 divided by 0.7041. That is 2.8169 divided by 0.7041. That is 4 approximately, and this is 1. Therefore, the empirical formula of this compound is Na2 rather, Na2, then O, O4, then S. Of course, we will rearrange these to Na2SO4. That is sodium tetrasulfate 6. Okay, that is question 10. Answered question 11. So 6 grams of metal M reacts completely with 23.66 grams of chlorine to form 29.66 grams of the metallic chloride. Find the empirical formula of the metallic chloride. Okay, you said the reacting mass of the metal is 6. The 6. Write the reacting mass under it. Then chlorine, the reacting mass is 23.66. 3.66. To find the mole ratio of each of these component elements, we divide by their respective relative atomic masses. That of the metal M is 27, while that of chlorine is 35.5. 6 divided by 27 is 0.222, and 23.66 divided by 35.0.6665. 0.6665, yes. Now we pick the smallest one and use it to divide through. This is the smallest one here. 0.2222. This is 1. And 0.666 divided by 0.2222 is 3 approximately. 3. Therefore, the empirical formula of the chloride is MCl3. Then question 12, a metal X forms 2 different chlorides if 12.7 gram of chloride A and 16.3 gram of chloride B contain 7.1 gram of 7.1 gram rather and 10.7 gram of chlorine respectively. Show that the figures agree with the law of multiple proportion. And to answer this question, so what does the law of multiple proportion say? Okay, the law of multiple proportion states that if two elements A and B combine to form more than one chemical compound, then the various masses of one element A, which combine separately with a fixed mass of the other element B, are in simple multiple ratios. Now, what is the law saying? You can have two elements combining with one another. In one condition, they may form a compound X. In another condition, they may form compound Y. What am I saying? Let's assume we have element A and B. They combine the same element A and B combined. In another condition, the compound formed is Y. That is what the law is saying, that if two elements A and B combine to form more than one compound, two elements A and B combine to form more than one chemical compound, then the various masses of one of the element A, which combine separately with the fixed mass of the other element B, are usually in simple multiple ratio. Now, examples of elements that behave like that, one of the examples is copper and oxygen. Sometimes copper and oxygen will combine to give black copper 2 oxide. Some other time they will combine to give red copper 1 oxide. There are two elements, the same element, copper and oxygen. Under one condition, they give copper 2 oxide. Under another condition, they give copper 1 oxide. Then iron and oxygen can do the same thing. Sometimes iron and oxygen will combine to form brown iron 3 oxide. Some other time they will combine to give black iron 2 oxide. Another example is iron and chlorine. Sometimes iron and chlorine will combine to give brownish yellow iron 3 chloride. Some other time they combine to give a green iron 2 chloride. And then finally lead and sulfur can do the same thing. Sometimes lead and sulfur can combine to give black lead 2 sulfide. Some other time they can combine to give lead 4 sulfide. So they give us some data there. That is the masses of the element that combined and the mass of the fixed element that is obtained. Now they are asking us to show that the data agree with the law of multiple proportion. So how can we do that? To do that, we need to know the same metal X forms two different chlorides. If 12.5 gram of chloride A, okay, they give us the mass of the chloride. Where's my marker? Okay. So mass of chloride A is equal to 12.7 gram. Why mass of chloride B is equal to 16.3 gram. Okay, these are the masses of the two chloride. Now, they said if 12.7 gram of chloride A and 16.3 gram of chloride B contain 7.1 gram and 10.7 gram of chlorine respectively. Okay, so mass of chlorine in chloride A, according to the question, is 7.1 gram. So if mass of chlorine in this chloride A is 7.1 gram, that means the mass of the metal X, because they say a metal X forms two different chlorides. That is, it is metal X that is combining with chlorine in this case. So now mass of the chloride A when S combined with chlorine is 12.7. The mass of chlorine in this chloride is 7.1. That means mass of the metal in that chloride, mass of metal X is equal to 12.7, which is mass of the chloride, 12.7 minus 7.1, which is mass of chlorine. So 12.7 minus 7.1, 5.6. If I round that to the nearest whole number, that is 7, and that is 6 rather. 6 round up to 1, then 1 added to 5, 6. So to the nearest whole number, it is 6. Okay, that is the mass of X in this chloride. We'll do the same thing for the second chloride. So mass of the second chloride, chloride B, is 16.3. In that 16.3, according to the question, mass of chlorine is 10.7 gram. So mass of chlorine in chloride B is equal to 10.7 gram. Therefore, mass of the metal X, mass of metal S is the mass of the chloride, which is 16.3 minus the mass of chlorine, which is 10.7. I'll leave a link to that. So 16.3 minus 10.7 is 5.6. 5.6, which is again approximately 6. So what can we say here? We can see that it's the same mass of metal X that we have in both chloride A and chloride B. So metal X, the masses in the two chloride are the same according to the law of multiple proportion. Now the law says if two elements A and B combine to form more than one chemical compound, then the various masses of one element A, which combine separately with the fixed mass of the other element B. So in this case, the one that has fixed mass here is the metal X. That in the first one, in metal B, in the chloride B rather, the mass of chlorine is 10.7. So, and since they asked us to show that this data agree with the law of multiple proportion, since the mass of metal X in both chloride are the same, then we can say that the data agree with the law of multiple proportion. So the fixed element in this case is the metal X, while the variable masses is chlorine. Okay, question 13 now. It says two different samples A and B of zinc oxide were obtained from different sources. When heated in a stream of hydrogen, they were reduced to yield the following results. Okay, in one of the sample, zinc oxide, the mass is 10.0 gram. Then the other sample, that is sample B, zinc oxide, the mass is 13.2. Then after reducing both of the sample by passing a stream of hydrogen through them, reduction reaction is removal of oxygen in this case. Then you have a residue, which is copper residue. In the first sample, the sample A, the copper residue there is 8.11 gram, while sample B, the copper residue is 10.7 gram. Then we have to show that the figures above illustrate the law of constant composition. And the law of constant composition states that the law of constant composition is also known as law of definite proportion. And it says that all pure samples of a particular chemical compound contain similar elements combined in the same proportion by mass. So how can we show that these figures here agree with the law of constant composition? To do that, we need to calculate the mass of the residue, which is already given to us. Then we express it in terms of percentage composition by mass. Since the law is what? Constant composition. Mass of sample A, which is the zinc oxide, is what? 10.0 gram. Then after reducing it to zinc residue is equal to 8.11 gram. The percentage by mass of zinc in this zinc oxide will be in zinc oxide of the sample A is equal to mass of zinc residue, which is 8.11, divided by the mass of the oxide, which is 10.0, multiplied by 100. 8.11 divided by 10, then multiplied by 100, that is 81.1. To the nearest 10, that is 80%. As I round it to the nearest 10. Then we'll do the same thing for sample B. So mass of sample A, sample B, mass of sample B, which is also zinc oxide, but prepared from 13.2 gram. After reducing it to zinc residue, the mass of zinc residue is 10.7 gram. 0.7 gram. Percentage by mass of zinc, percentage by mass of zinc in this zinc oxide is equal to mass of the zinc residue, which is 10.7, divided by mass of the oxide, which is 13.2, then times 100. 10.7 divided by 13.2, then multiplied by 100. So you give us exactly the same thing, 81.1. 81.1 to the nearest 10 is also 80%. And that agree with the law of constant composition, which says that pure samples, all pure samples of a particular chemical compound contain similar elements combined in the same proportion by mass. So now, this is zinc residue obtained from two different samples of zinc oxide. According to the question, you say two different samples, A and B. So we get zinc oxide from different sources. After analysis, we discover that the amount of copper in both of them is what? 80%. 80%. That agree with the law of constant composition or definite proportion. All pure samples of the same chemical compound contain the same elements combined in the same proportion by mass. So for example, if you get water, as long as the water is pure, it contains hydrogen and oxygen with a ratio of 2 to 1. Question 14 say balance the following equations. The first one here says potassium chlorate and potassium trihydrochlorate 5 is a solid, then when heated, it decomposes to potassium chloride and oxygen. Now we have to balance the equation. On the left hand side, the reactant side, I have one potassium there. On the product side, also one potassium, one chlorine, three oxygen, two oxygen. So it's oxygen that is not balanced. Let's start by balancing the oxygen by putting a 2 here on the product on the reactant side. Then these two now affect both chlorine and potassium. So I'll put the same 2 here to balance the chlorine and the potassium. And these two also affect oxygen. 2 times 3 is 6. To balance it on the product side, we put 3 here. So 3 times 2 is 6. And that equation is balanced. Then the second one, we have carbon plus water, giving us carbon monoxide and hydrogen. To balance this, carbon is 1 on the reactant side. On the product side is also 1. Hydrogen is 2. Is also 2 on the product side. Oxygen is 1. Is also 1. Then the equation is balanced. What else do they want us to do? This one is balanced. No need of balancing anything there. The equation is balanced. Or is anything that's missing in the equation? This one is balanced. Then the third one, NH3 plus O2, giving us H2O plus N2. Okay. Nitrogen is 1, but on the product side is 2. So nitrogen is not balanced. Also, hydrogen on the reactant side is 3. On the product side is 2. So hydrogen 2 is not balanced. Oxygen on the reactant side is 2. On the product side is 1. Short, all the elements are not balanced. So let's start by putting the 2 here to balance nitrogen, and then that affects hydrogen, making hydrogen to be 6 now. That is 2 times 3. Then if I put a 3 here also, but that will disturb the balance of oxygen, because on the product side I have 2 oxygen. So what can we put here? What if we put 4 here? And that will make hydrogen to be 8. But here I have 6. So 4 will not work. Let me use a different number. We use 5. Let's use 6 and see. 6 hydrogen. 6 times 2, that is 12 hydrogen. Then plus this 6 I'll add the oxygen, that is 6 oxygen there. So I'll put 3 here to make oxygen 6 on the product on the reactant side also. Then what about nitrogen and hydrogen? Hydrogen on the product side is 12. To make it 12 here, I'll put 4 here. That is 4 times 3, 12. And this 4 affect nitrogen too. So we'll put 2 here to make to balance the nitrogen. That is 2 times 2, 4. So the equation is balanced. Now again, let's do atom count. 4 nitrogen, 2 times 2, also 4. Then this 4 multiplied by this 3, that is 12 hydrogen. 6 times 2, that is 12 hydrogen also. Then oxygen, this is affect this oxygen here, which means there are 6 oxygen on the product side. On the reactant side, 3 times 2, 6. So the equation is not balanced. Then the next one, copper sulfide solid plus oxygen gas, giving us copper oxide solid and sulfur oxide gas. Okay, let's balance that. Doing atom count, sulfur on the reactant side we have 2 copper, on the product side also 2 copper, then sulfur 1, also 1, oxygen 2, oxygen 3 on the product side. So oxygen is not balanced. So let's start by putting a 2 here. I like starting from where I have odd number of atoms. So I have odd number of oxygen here. So I put a 2 there to make it even number. And that makes oxygen to be 4 on the product side. Then I'll put a 2 here to balance the oxygen. But this 2 here affect this copper here, making copper to be what? To be 4. 2 times 2, 4 on the product side. So we put 2 here also to make copper 4 on the reactant side. That is 2 times 2. But the 2 affect this sulfur also. So we put a 2 here to balance the sulfur. That makes oxygen to be a total of 2 times 2, 4, plus 2 here, that is 6. 6 oxygen. Therefore, to balance the oxygen here, we have to make this 3. So 3 times 2, 6. Okay, let's do atom count. Copper is 2 times 2, you have 4. The same thing here, 2 times 2, 4. Sulfur 2, sulfur 2. Then oxygen 3 times 2, 6. Oxygen on the product side, 2 here, plus 2 times 2 here, 2 times 2 here, 4, plus the 2 here, 6. So the equation is not balanced. Question 15 is how many atoms are there in 1 mole of hydrogen gas? 1 mole of any substance, in this case hydrogen gas, contains 6.02 times 10 to the power 23 atoms according to Avogadro's constant. 1 mole of any substance has this number of elementary entities. In the case of a mole of hydrogen, hydrogen is an element, so the elementary entity of it should be atoms. So the number of atoms in 1 mole of hydrogen is 6.02 times 10 to the power 23 atoms. Question 16 is what is the percentage by mass of sodium in sodium hydroxide? Sodium hydroxide is NaOH. Relative molecular mass will be the sum of the relative atomic masses of the component elements. Sodium is 23, oxygen is 16, hydrogen is 1. Adding all this together, that is 40. Now, out of this 40, what is the mass of sodium? The mass of sodium is 23. Therefore, percentage by mass of sodium is equal to 23, the mass of sodium, divided by the relative molecular mass of sodium hydroxide, multiplied by 100. Now, 23 divided by 40, then times 100, 57.5. Question 17 says how many molecules are there Or how many molecules of white phosphorus are contained in 248 gram of the substance in 248 gram of phosphorus. And recall that number of moles is the mass over the molar mass equal to mass over molar mass. Now, what is molar mass of phosphorus? Since it's an element, the molar mass is the same thing as the atomic mass here. Molar mass of phosphorus is approximately 31. Therefore, number of moles of in 248 gram of phosphorus will be 248, which is 8 moles. Now, 1 mole of any substance contains 6.02 times 10 to the power 23. So they ask us what is the question? How many molecules? So in this case, molecules. Therefore, 8 mole will contain 8 times 6.02 times 10 to the power 23. Now, 8 times 6.02, that is 48.16 times 10 to the power 23. Let's express this as a proper standard form by moving this decimal point to this position. So that will be 4.816 times 10 to the power 24 molecules. Since we moved the decimal point in one position, so we need to add that one to this 23. That makes it 24. Then question 18 says, which of the following contains the greatest number of moles? A, 8 gram of helium. B, 48 gram of carbon. C, 78 gram of potassium. And D, 130 gram of zinc. To ask in moles, the mass divided by this element will give us the number of moles of each of them. So for the first one, we say 8 gram of helium. So number of moles then will be 8 divided by molar mass of helium. What is molar mass of helium? Molar mass of helium is approximately 4. So the number of moles in 8 gram of helium will be 8 divided by 4, which is 2 mole. Then question B, 48 gram of carbon. Number of moles there will be the mass, which is 48, divided by molar mass of carbon. Molar mass of carbon is 12. When we say molar mass, we mean the mass of 1 mole. And for carbon and all the monoatomic elements, their relative atomic mass is the same thing as their molar mass, because 1 mole of carbon is the same thing as the 1 atom of carbon, since carbon is monoatomic. So 48 divided by 12 moles. And question C, 78 gram of potassium will be 78 divided by the molar mass of potassium. The molar mass of potassium is 39. So 78 divided by 39, that is 2. So 2 moles. And the last one, 130 gram of zinc. Number of moles there is equal to the mass, which is 130 gram, divided by molar mass of zinc. Molar mass of zinc is 65.5 or 65.4 approximately. Let's use 0.4. 65.4 is 1.98 or 1.99 approximately. And now the question says, which of the following contains the greatest number of moles? So let's compare the answer. The greatest here is 4 mole. Look, and that is option A, which is option B rather, which is 48 gram of carbon. So 48 gram of carbon contains the greatest number of moles. Then question 20, it says what is the mass of 6.02 times 10 to the power 24? This 10 to the power 24 atoms of magnesium. Remember that number of moles is equal to mass, reacting mass over molar mass, and 1 mole of any substance, in this case magnesium, has 6.02 times 10 to the power 23 atoms. So if that is the case, and the question is asking what is the mass of this number of atoms? So how many moles are there in this 6.02 times 10 to the power 24? We need to know that first. So X mole of magnesium is 6.02 times 10 to the power 23, 24 rather. That's the value given there, 10 to the power 24. 10 to the power 24 atoms. So that by proportion, X is equal to, we cross multiply 6.02 times 10 to the power 24 times 1, still remain at 6.02. Then we divide it by this. So X is equal to 6.02 times 10 to the power 24 divided by 6.02 times 10 to the power 23. Of course, this will cancel. 10 to the power 24 divided by 10 to the power 23 is 10. So the number of moles there is 10 mole. But the question asks what is the mass? Number of moles is equal to mass over molar mass. Therefore, 10 is equal to mass over molar mass of magnesium. Molar mass of magnesium is the same thing as the relative atomic mass. So relative atomic mass expressed in gram gives the molar mass of magnesium. Magnesium is monoatomic, so that will be 24. So that when we cross multiply this, the mass is 10 times 24, which is 240 grams. And question 21, it says the valences of two elements X and Y are 2 and 3 respectively. Write down the formula of the compound formed when X and Y combine. Well, is the combining power of elements. So now they give us two hypothetical elements, X and Y. X, the valency is 2, Y, the valency is 3. And we are to write the formula formed when X and Y combine. When they combine, they are going to exchange their valency. That is why we define valency as the combining power. So why we pick these two coming from X, why X we pick the 3 coming from Y, so that their formula becomes X3, Y2. Question 22, it says trichloromethane consists of 10.05% carbon, 0.83% hydrogen, and 89.12% chlorine. Its relative molar mass is 119.5 gram. Find its molecular formula. Now, let's list all the component elements with their respective percentage composition by mass. So the first element here is carbon. The percentage composition by mass is 10.05%. The next one is hydrogen. The percentage composition by mass is 0.83. And then the next one is oxygen, chlorine rather. Chlorine, the percentage composition by mass is 89.12. To express the mole ratio in which they are combined, we need to divide each of these composition by mass by the relative atomic mass of each of the component elements. Relative atomic mass of carbon is 12, that of hydrogen is 1, and that of chlorine is 35.5. 10.05 divided by 12, that is 0.8375. Then 0.83 divided by 1 still remains at 0.83, and 89.12 divided by 35 point, that is 2.5104. Now, to know the ratio in which these elements are combined, we need to divide this number by the smallest value in this case. The smallest value is 0.83. That divide through by 0.83, 0.83. Of course, the first one, 0.8375 divided by 0.83 still remains as 1, approximately 1. Then this 2 is 1. Then 2.5104 divided by 0.83, approximately 3. Therefore, the empirical formula is CHCl3, trichloromethane. That is the name. Then, but they ask us to calculate the molecular formula. They give us the relative molar mass. Empirical formula multiplied by n is equal to relative molar mass, 119.5. Now, expressing this in terms of their relative atomic mass, carbon is 12, hydrogen is 1, chlorine is 35.5, but you have 3 atoms there, so that will be 35.5 times 3 for chlorine. Then multiply by n equal to 119.5. 35.5 times 3, 106.5, then add to 1 and to 12. That is 119.5. The 119.5 n is equal to 119.5. Now dividing both sides by 119, n equal to 1. Like we learned earlier that some compound, their empirical formula and their molecular formula are the same. So a good example is this trichloromethane. Since n is equal to 1, 1 times each of these atoms is still 1. So the molecular formula is CHCl3. That is trichloromethane. Question 23 says calculate the percentage of water of crystallization in magnesium tetrasulfate 6 heptahydrate, molecular mass of magnesium tetrasulfate 6 heptahydrate. And that we can get by summing up the relative atomic masses of all the component elements. Magnesium is 24. So 24 plus sulfur is 32, oxygen is 16 times the 4 atoms there, then plus this 7, the hydrated water here, the 7 affect both hydrogen and oxygen. So let me put it like this, 7 times hydrogen is 1, then multiply by the 2 atoms, that is 2, then plus oxygen 16. So we have 24 plus 32, 16 times 4, 64. Then plus 2, 2 plus 8 is 18, 18 times 7, 126. Adding all this together, that is 246. But the question asks us to calculate the percentage of water crystallization. Now, what is the water crystallization? That is this 7H2O, the hydrated part of the salt. And that is this 7 times 2 plus 16. That is the water there, the mass of water there, which is 126. Therefore, percentage of water crystallization, let me shorten it to crystal, is equal to mass of water crystallization, which is 126, divided by mass of the whole salt, which is 246, times 100, and that is 51.2. So percentage of water crystallization is 51.2%. Question 24, it says find the empirical formula of a substance which has the following percentage composition by mass. Sodium is 18.2%, oxygen is 19.1%. Okay, to do that, we need to list out the components, elements, or group. In this case, because water crystallization, I would consider it to be a group. So we have sodium there, and the percentage by mass is 18.2. We have sulfur, the percentage by mass is 12.7. We have oxygen, the percentage by mass is 19.1. Then water crystallization, I'm taking it as a group, H2O, the percentage by mass is 50%. Dividing each of these by their respective relative atomic masses, that of sodium is 23, sulfur is 32, oxygen 16, water crystallization. Water, that is hydrogen and oxygen. Hydrogen is 2 here, oxygen 16, that is 18 altogether. 18.2 divided by 23, 0.7913. Then 12.7 divided by 32, 0.3969. 19.1 divided by 16, 1.1938. And then 50 divided by 18, 2.7778. Now we divide by the smallest number to know the mole ratio in which these elements are combined. The smallest one here is 0.3969, 0.3969, 0.3969, and 0.3969. Now, starting with the first one, 0.7913 divided by 0.3969. That is 2 approximately. It's 1.999. When you round it up to the nearest number, that is 2. Then this is 1. Then 1.1938 divided by 0.3969. That is 3 approximately. Then 2.7778 divided by 0.3969. That is 7 approximately. Now recall that this 7 is for a group, which is water crystallization. So this is not number of atoms, rather is number of moles, since I'm taking this as a group. Unlike this other one for sodium, sulfur, and oxygen, this is going to be placed as the number of atoms. So that the empirical formula is Na2, SO3, then 7H2O. So this is the empirical formula of the salt. That is sodium sulfate, whatever. We need to calculate the valency of sulfur here before we know the right name, but that is beyond the scope of this class. Question 26. Say consider the following equation: 2 mg rather magnesium plus oxygen giving us magnesium oxide. Calculate the mass of magnesium oxide that will be produced by 1 mole of magnesium. Okay, in this equation, it is 2 mole of magnesium that give us this 2 mole of magnesium oxide. Now, that the question is asking us calculate the mass of magnesium oxide that will be produced by 1 mole. So if 2 mole of magnesium give, first of all, we need to get the molar mass or the mass of this 2 mole of magnesium oxide. The mass of 2 moles, mass of 2 moles of magnesium oxide is 2 times magnesium is 24, oxygen is 16. 24 plus 16, that will be 40. And 40 times 2 is 80. That means in this balance equation, 2 moles of magnesium gives 80 grams of magnesium oxide, 2 moles of magnesium gives 80 gram of NGO. But the question says calculate the mass of magnesium oxide that will be produced by 1 mole. So what will 1 mole of magnesium give? Let it be X. So that by proportion, when we cross multiply X times 2 is 2X. Then 1 times 80 is 80. Therefore, X is 80 divided by 2, and that is 40 gram. So the mass produced by 1 mole of magnesium should be 40 gram. Question 27. In the reaction represented by the equation, sodium chloride, 2 moles of sodium chloride, aqueous, plus H2SO4, giving us sodium sulfate and HCl. The equation has been balanced for us already. The equation says calculate the volume of hydrogen chloride gas that can be obtained at STP from 5.85 gram of sodium chloride. Okay, from this balance equation, mass of 2 moles of sodium chloride is equal to 2 times sodium is 23, chlorine is 35.5. That's their relative atomic masses. Now 23 plus 35.5, 58.5. Then multiply by these two outside. That is 117, 117 gram. That is the mass of 2 moles of sodium chloride in this balance equation. Now the question borders on, where is the question? It says calculate the volume of hydrogen chloride gas. So I won't calculate this because the question is on this. So 117 gram of sodium chloride gives 2 moles of hydrogen chloride gas. And the question borders on volume. So 117 gram balance equation give us 2 moles of HCl according to the equation there. That is 2 moles of HCl. And we know that 1 mole of any gas, HCl in this case is gas. We didn't put the state of the reaction. This is aqueous. This one too is aqueous. This one is aqueous. Now, 1 mole of any gas at STP, because the question says calculate the volume obtained at STP. So 1 mole of any gas at STP has a volume of 22.4 dm cube. But from this balance equation, we have 2 moles of hydrogen chloride gas. Therefore, this 117 grams of sodium chloride, which gives 2 moles of HCl, in essence, give 2 times 22.4 dm cube of HCl. So let's use that 117 gram NaCl give us 2 times 22.4 dm cube HCl. Then what would 58.85 gram, what will it give? 5.85 rather. So 5.85 gram of sodium chloride gives X. By proportion, we cross multiply. 117 times S is 117X equal to 58. What am I calling 58? 5.85 times 44.8. That is 2 times 22.4 is 44.82, right? So 44.8 dm cube. So that S equal to, remember this 117 is in gram, this 5.85 is also gram. So in essence, the gram will cancel out when I divide. So that what we are left with is dm cube. So of course, the question is asking us to calculate the volume. So S equal to 5.85 times 44.8 divided by 117. 5.85 times 44.8 then divided by 117, 2.24. So the volume of HCl is 2.24 dm cube. Alazine with the formula C5H8NO5 is a new drug used for the treatment of malaria. Determine the molecular formula of alazine if its relative molecular mass is 284. So the question says an empirical formula of C5H8N then O5. It has a relative molecular mass of 284. We have to determine the molecular formula. So this is the empirical formula given to us. And the empirical formula multiplied by N gives the relative molecular mass, right? So now expressing each of the component elements in terms of their relative atomic masses, we have carbon is 12 multiplied by the number of atoms there, which is 5. Hydrogen 1 multiplied by the number of atoms, which is 8. Then multiplied by this N outside, plus oxygen outside also, 16 times 5 equal to 284. 12 times 5, that should be 60, right? So 60 plus 8 times n plus 16 times 5, 80. equal to 284. That means 68, that is 60 plus 8, then multiply by this n, 68n plus 80 equal to 284. 68n therefore is 284 minus 80. 68n is equal to 204, and therefore is 204 divided by 68. That is 3. So n is 3. Now, if n is 3, therefore the molecular formula of that drug will be C5H8. Instead of times n, we now know the value of n, which is 3. So times 3, then oxygen. We have 5 atoms of oxygen, then the empirical formula. So oxygen 5. Then we writing this 3 times 5 is 15. So C15. Then 3 times this 8, 24. H 24. And then O5. This is the molecular formula of the drug, alazine. Question 30. What is the empirical formula of the hydrocarbon containing 0.08 moles of carbon and 0.32 moles of hydrogen? Okay, so the hydrocarbon, carbon and hydrogen, it has 0.08 moles of carbon and 0.32 moles of hydrogen. The number of moles is already given, so we just need to calculate the mole ratio, the ratio in which they are combined rather, by dividing through by the smallest one, which is 0.08 in this case, and dividing by 0.0, that will be 1 here. So, therefore, the formula is CH4, that is methane gas. Then question 31, determine the molecular formula of an alkane whose vapor density is 15, given that relative molecular mass is equal to 2 times vapor density. So now they give us the vapor density of this alkane. We have to find the molecular formula of the alkane. Now what type of alkane? Okay, all alkane has the general molecular formula of alkane is CnH2n plus 2. And now they give us the vapor density, which is 15. Relative molecular mass is 2 times vapor density. So 2 times 15 is 30. So carbon is 12, 12n plus hydrogen 1, then 1 times 2, that is 2n, then plus this 2 equal to 30. 14n plus 2 equal to 30. 14n equal to 28. That is 30 minus 2. N equal to 28 divided by 14, which is 2. Therefore, the alkane is C2, H, 2 times 2, 4, plus Z is 6. Let's see. So the compound, the hydrocarbon is ethane, C2H6. Look at the structure, C2H6. So when a question like this is given, they didn't specify the type of hydrocarbon, the type of alkane rather. Where is it? That is question 31. We say determine the molecular formula of an alkane. The alkane is not specified. Whose vapor density? But we know the vapor density. So here we have to use the general molecular formula of all alkane, which is CnH2n plus 2. Now we just find the value of n by expressing each of these component elements in terms of their relative atomic mass. The relative atomic mass of carbon is 12, hydrogen is 2, but there are 2 times 2 there. That's I have 2n. Then plus this 2, which is coming from the general molecular formula or the general family formula of all the alkane. Yes, I'm right. General molecular formula of all the alkane. Then equal to 30. Where did I get 30 from? The vapor density is 15. Relative molecular mass is 2 times vapor density. So 2 times 15 gives me 30. So using that to find the value of n from the, so that I can know the type of alkane. And n is 2. So if n is 2, when I substitute the 2 here, that is C2, then 2 times 2, 4, plus this 2, 6. And the alkane that has C2H6 is ethane. Question, I didn't number this. It said from the following equation, sodium hydrogen triisocarbonate 4, 2 moles of that, sodium hydrogen triisocarbonate 4 is a solid. It decomposes to give sodium carbonate, also a solid, plus carbon dioxide, a gas, and water, that is gaseous water, steam. So we should determine the mass of residue formed if 1.68 gram of sodium hydrogen carbonate is decomposed. Okay, mass of residue formed. What will be the residue formed in this case? When you heat up this, it decomposes to give this product here on the right hand side. The two products here, CO2 and H2O, are gases, and so they are going to escape into the atmosphere. So the residue will be this sodium carbonate. So in essence, they are asking us to calculate the mass of sodium carbonate formed. So in this case, first of all, I need to know the mass of sodium hydrogen carbonate. from the balance equation, mass of sodium hydrogen carbonate is 2 times sodium is 23, hydrogen is 1, carbon is 12, oxygen is 16, then times the 3 atoms. That will be 2 times 23 plus 1 plus 48. 23 plus 1, 24, 24 plus 48, 72 times 2 144. That is the mass of sodium hydrogen carbonate that decomposes. And now it gives us 1 mole of sodium carbonate. So we need to get a mass also. Mass of sodium carbonate, sodium 23 times the 2 atoms, then plus carbon 12, oxygen 16 times the 3 atoms. And this is 23 times 2 is 46, then plus 12 for carbon plus 48, that is 16 times 3. Adding up that, 46 plus 12 plus 48, 106. Meaning 144 grams of sodium hydrogen carbonate give us 106 grams of sodium carbonate. But the question says, where is it? Determine the mass of residue formed if 1.68 grams of sodium hydrogen carbonate is decomposed. So these values we have here is from this balanced equation. So according to the balanced equation, 144 grams of sodium hydrogen carbonate gives 106 grams of sodium carbonate. Then what would 1.68 gram give? 1.68 gram of sodium hydrogen carbonate will give X. Now, by proportion, we cross multiply this. X times 144 is 144x. And 1.68 times 106. So that S equal to 1.68 times 106 divided by 144, which is 1.24 gram. So the mass of residue formed is 1.24 gram. Question 32. What mass of water is produced when 8 gram of hydrogen reacts with excess oxygen? Hydrogen gas plus oxygen gas will always give us water. And the equation is not balanced. Let's start by putting a 2 here to balance oxygen, and that makes hydrogen to be 4, so we have to put 2 here too. And now the question says what mass of water is produced when 8 grams of hydrogen react with excess oxygen. So the question borders on hydrogen and water. So from this balance equation, mass of 2H2, that is 2 moles of hydrogen, is 2 times mass, relative atomic mass of hydrogen is 1, but there are 2 atoms there. Then multiply by these 2, which is 4 grams. Then mass of 2 moles of water that are formed, 2 moles of water is 2 times 2 plus 16. 2 for hydrogen, because 1 atom of hydrogen is 1, but there are 2 there. Then oxygen 16. That is 2 plus 16, 18. 18 times 2, 36 grams. So from the balance equation, 4 grams of hydrogen gives 36 grams of water. What would 8 grams give? According to the question says what mass is produced when 8 grams of hydrogen react. So 8 grams of hydrogen, let it produce X. So by proportion, S equal to cross multiply divided by 4, which is 2 times 36, 72 grams. 33 says consider the reaction represented by the following equation. What mass of hydrogen will be produced if 12 grams of magnesium react with excess dilute hydrochloric acid? Okay, so let's write the equation of reaction first. Magnesium solid plus 2 moles of HCl aqueous, giving us magnesium chloride aqueous plus hydrogen gas. Now the question says what mass of hydrogen would be produced if 12 grams of magnesium reacts with excess dilute hydrochloric acid. So the question borders on hydrogen and magnesium. So in this case, from the balance equation, this equation is balanced using magnesium 1, 1, hydrogen 2, 2, chlorine 2, 2. So the equation is balanced. From the balance equation, mass of magnesium, we only have 1 mole of magnesium there, that is 24 grams, and mass of hydrogen formed is 2 grams, 2 grams. Now, so we can say that 24 grams of magnesium produce 2 grams of hydrogen from the balance equation. Then what would 12 grams of magnesium produce? 12 grams of magnesium, let it produce X. Simple proportion, that would be 12 times 2 divided 24. That is cross multiplication. 12 times 2 is 24. 24 divided 24 is 1. So 1 gram of hydrogen will be produced. Then 34, consider the following equation, reaction. Find the value of X, Y, and Z. I want to balance the equation. We have magnesium oxide and manganese oxide. Manganese oxide is solid. It reacts with X mole of HCl, which is aqueous, to give us magnesium chloride, manganese chloride, not magnesium, manganese chloride is aqueous, plus Y mole of chlorine, gas, and Z mole of water, liquid. So I have to find the value of X, Y, and Z. So let's balance the equation. Manganese oxide, solid, plus HCl, aqueous, giving manganese chloride, aqueous, and chlorine gas, and H2O, liquid. On the reactant side, I have one atom of manganese. On the product side is also one atom. Oxygen 2, oxygen 1, hydrogen 1, hydrogen 2, chlorine 1, chlorine 2. Okay, so let's start by putting a 2 here. That makes hydrogen to be 2. Here is also 2. Chlorine 2 is also 2 here. The only thing that is not balanced yet is oxygen. Oxygen is 2 here. Here I have only 1. Let's put 2 here to balance the oxygen, but that makes hydrogen to be 4. That means we need to put a different number here, maybe 4, but that will affect chlorine and make chlorine to be, oh, chlorine is actually 4 here on the product side. So the equation is now balanced. Look at it. 4 hydrogen, 2 times 2. This 4 affects chlorine also. That makes chlorine to be 4 on the reactant side. You have 2 chlorine here, another 2 chlorine there, 4. Manganese 1, manganese 1. Oxygen 2, oxygen. These two affect oxygen 2. So the equation is balanced. Now they ask us to find the value of X. So X corresponds to 4, Y corresponds to 1. Look at it there. Y is 1. Then Z is 2. Z is 2. And finally, the hydrocarbon contains 88.9% carbon. What is the empirical formula of the hydrocarbon? They give us only 1% there. Does it mean the question is not correct? It is correct. A hydrocarbon is only. And so if the percentage by mass of carbon is 88.9%, percentage is out of 100. So 88.9 is 88.9. And that would be the percentage by mass of hydrogen. So carbon is 88.9%. That means hydrogen is equal to 100 minus 88.9%, which is 100 minus 88.9 is 11.1. Okay, so now let's write the percentage by mass of each element under it. Carbon is 88.9. And to find the mole ratio, we divide by the relative atomic mass. That of hydrogen is 11.1. To find the mole ratio, we divide by the relative atomic mass. And that of hydrogen is 1. 88.9 divided by 12, 7.4083. And then 11.1 divided by 1 is still 11.1. Then we divide by the smallest ratio, which is 7.4083. 7.4083. This will be 1. 11.1 divided by 7.4083. 1.49. Let's round it up to 2. Approximately. So 1.49. If I round this 9 and add it here, that is 1.5, which I can round to approximately. So that the empirical formula of that, and that brings us to the end of the revision exercise.